4, 4, 4, 5. We got 12-foot ladder stands against a vertical wall. So you got some wall. And then we got the ground down here, and we're going to assume that makes a right angle. And then you have a ladder leaning up there against the wall. And we can write 12 foot for the ladder because the ladder's length is not going to change. It's stuck in stone, so anything that doesn't change, you can put the number in right away. And it says that the lower end of the ladder is being pulled away. So this end of the ladder is going in this direction. We're going to call this X because as the ladder moves, this X changes. So this is not in stone, this is changing. And as the ladder goes out to the right, the top of the ladder is coming down. And this Y value about how far this ladder is up the wall is also changing because as the foot of the ladder goes out, the top of the ladder is coming down. Anybody ever had a good experience of riding a ladder down the wall? I have not either, and I hope I never do, but I saw a guy do it once. Didn't look like much fun when he hit the ground. All right, so how fast is the top of the ladder moving down the wall? The instant it is 6 feet above the ground. So how fast the ladder is moving down the wall means we're looking for the change in Y. How's the Y value changing the exact second that Y is at 6 feet? So before you hit the ground, we're going to find out how fast you're coming down. Woo! So what we need to do is we need to figure out how X, Y, and 12 relate to each other. And I think we all probably know that X squared plus Y squared is going to equal 12 squared. And then to get a dy dx, oh, something else I forgot, the bottom of the ladder is being pulled away at 2 feet. So that's dx dt, I missed that, that's up here. The dx dt is equal to 2 feet per second. Okay, so x squared plus y squared equals 12 squared, so I get 2x dx dt. This is implicit differentiation because we're doing the derivative with respect to t, but we're doing x. And then we're doing it with respect to t, but we're doing y, so we got to put dy dt. And whenever you do the derivative of a number, it's always 0. 12 squared is just a number. So we got to plug in all this information. Now, I would simplify this by dividing everything by 2 first. So that would get rid of that 2 and this 2. And you don't have to do that first. It just makes the numbers smaller, and then I can do them in my head easier. Okay, so I got to plug in all the numbers I know. Well, I know y is 6 feet, so I'm going to put a 6 here. I know I'm looking for dy dt, so this is going to stay dy dt. And then I know that dx dt is 2 feet per second, so I'm going to stick 2 in here. That's feet per second. And then x, I got to find x. Well, what I'm going to use to find x is Pythagorean theorem because we want this when y is 6. So when y is 6, we can find what x is at that exact time by plugging 6 in. So x squared plus 6 squared equals 12 squared is going to be that x squared plus 36 is going to equal 144. And subtracting 36 from both sides, let's see, what's that going to be? 108? I believe that's 108. So x is the square root of 108, which is not a pretty number. So we're going to stick in here the square root of 108. Remember, you don't have to simplify square roots. You can if you want, but you don't have to. So we got to solve this for dy dt. So we're going to subtract this over to the other side. So that's going to be negative 2 radical 108 is going to equal 6 dy dt. And then we're going to divide that by 6. So dy dt is going to equal negative 2 times the square root of 108 all over 6. And this again is the rate the ladder's coming down, so it's going to be feet per second on this problem. Now you can go through here and put all your variables in here. Like when I got this x, this is feet, right? So this is feet, and this right here is feet per second, and this is feet. Okay, so when you got feet squared over here per second. So this part over here is actually feet squared per second because you got a foot times a foot over second, right? And then this 6 is feet. So when you take foot squared per second and you divide it by feet, this was feet squared per second divided by feet. I hope you see that this 1 foot would reduce with one of these feet. That's why it's feet per second. So if you want to write the units down each time, you can, but that's how they work, just like variables. Is that okay?
There's a part B too.
Oh, part B. Let's come over and do part B. How fast is the angle of elevation changing at that instant? So in other words, the angle of elevation is from a horizontal going up. We're going to call that theta. Okay, we want to call that theta. So we are looking for d theta dt is what we want to find at the instant y is equal to 6. And we just said when y was 6 feet, we found on that problem a second ago that x was 108, the square root of 108. Again, if you want to simplify that, you can. So what actually, there's more than one way to do this. We want d theta dt. So we could use tangent and do y over x. Or we could do cosine and do x over 12. I don't know. What do you want to do? We do x over 12, then we only have one variable, or two variables, theta and x. So let's do that one. Okay? So we can say that the cosine, this is SOHCAHTOA I'm doing right now, the cosine of theta is x over 12, which is the same as 1/12x. That's how they relate to each other. So when I do the derivative of cosine, I'm going to get negative sine theta times d theta dt is going to equal 1/12 dx dt. Now again, I could have used tangent and used x and y both, but anyway, as long as the triangle works, it doesn't matter. All right, so we need to find this theta value when x is square root of 108. So I'm going to redraw this over here. So at the instant this is 108, this is theta, and this is 12. That means cosine of theta is equal to the square root of 108 over 12, and this should have been 6 here, right? So if I want the sine of theta at that exact instant is 6 over 12, right? So I can plug inside of sine theta 6/12 or a half. So this is going to be negative a half d theta dt is going to equal 1/12 times, what was that, 2 feet per second. Okay, so that 12 and that 2 reduces to 1/6, so I'm going to multiply by negative 2. So when I multiply 1/6 by negative 2, d theta dt is going to be a negative, and the 2 and the 6 will reduce to negative 1/3. And the way you do angles in this class is radians per second. So this should be negative 1/3 radians per second is the speed at which that angle is coming down when the y is 6. Question on that? All right. What else we got? Anything else you guys want to go over?
On the practice test,
Yep.
the very last problem.
All right, let's look at the practice test and the very last problem. I'll just go ahead and record that too. I gotta pull up that piece of material. I think I did this one yesterday, but I don't know. I'm pretty sure I did. I think it's on there. Does anybody know? I'm going to do it again. Talking number 15, right?
Yeah, just the, I have an answer, I just didn't know the conditions.
The answer's 2.
Yeah, I have to. I just didn't know what to write to be sure to say any conditions.
What that means is when you're gonna, we use L'Hopital's what we're looking at here.
Yeah.
So the condition that must be met is that you were supposed to tell me that the limit, I'm sure I did this yesterday. Oh, that's a T, not an X. And I think I put an X in there too. As T approaches 0, you were supposed to do this. You're supposed to tell me that that is 0.
Yeah.
And then you were supposed to separately tell me that as T goes to 0, for sine of T, that that is 0. That's the indeterminate, that is telling you that it's indeterminate, and so because this is true, we can use L'Hopital.
Okay. So it just means to show.
You have to show me that it's one of those indeterminate forms that are in our notes that I did in your note packet. And then you do the derivative of the top one, which would be 2e to the 2t, and the derivative of the bottom one would be cosine of t as you do the limit. As t goes to 0, and when you plug 0 in here, you get 2 times 1 is 2, and the cosine of 0 is 1. Okay? Anybody else got anything while I'm recording this? All right, so we're going to quit the recording. Does anybody have any questions about anything going on in here?